Alright, so welcome back to my channel, Math and Language, and we're going to tackle physics, projectile motion. In our previous video, diniscuss natin ang horizontal motion sa kinematics at kinematics sa free fall. So, review lang tayo ng kinematics formulas. Lagi ko lang dito yung sa vertical free fall at horizontal motion. Lalagay ko lang to for your reference. Meron tayong ibang formula na gagamitin sa projectile motion. So, let's move on to the projectile motion notes. So, first one, acceleration or G is plus minus 9.8 meters per second square. Depends on the question. So, bakit depende? For example, ang tinatanong is yung time or distance, ito yung mga scalar quantity. So, hindi mo kailangan ng negative doon. So, medyo makaka-apekto pag nilagay mo yung negative. So, for this one, depende pa rin yung sa tanong kung ipa-plus or ima-minus mo yung 9.8 meters per second square. Second, time to top is equal to time to come back down. So, kung yung projectile ng isang object pupunta sa taas, tapos bago siya pumaba, parehas lang yon. Yung sa pataas niya at yung pababa, same lang din siya. Pangatlo, distance and speed only take the positive value. Again, for scalar quantity, palaging positive lang yan. So, make sure kung ang sagot ay negative, you have to make it positive. Depende din sa tanong. So, be careful. And lastly, velocity on the horizontal component or yung Vx, hindi kaka-apekto dito ang gravity. So mapapansin mo sa mga problem solving natin, bakit parehas pa rin ang Vx na value. So we will tackle it later. Alright, moving on. Sa projectile motions, meron tayong 3 types. Okay, sa type 1, papansin mo, ito yung mostly nasa cliff ka, tapos may initial velocity yung bola at nahulog siya. Okay, A to B, yun lang. Second naman, level ground. Sinipa yung bola with an angle, tumaas, tapos bababa. So, ground lang siya, okay? Type C naman, yung bola sinipa from a cliff, sinipa pataas. So, pataas siya with an angle, tapos bababa. A, B, and C. Pinakamahirap dito yung type 3. Kaya kung alam mo paano pagganahin yung type 1 and type 2, alam nyo paano isolve, magiging mas madali itong isolve tong type 3. Alright, so let's move to the problem solving type 1. Number 1, a ball is kicked horizontally off the hill with a height of 25 meters and lands a distance of 40 meters from the edge of the hill. What is the initial velocity of the ball? Okay, so inahanap natin dito is initial velocity. Meron tayong binigay na height na 25 meters, so nasa hill daw siya, at yung 40 meters, that's the range. Yung distance ng base ng hill doon sa ilapagan ng bola. So, from B doon sa base ng hill, that's 40 meters. So, ang tawag doon ay range. Right, so lagay ko lang yung mga projectile motion formulas na gagamitin natin at yung given. So, for the given, we have height is equal to 25 meters and the range is 40 meters and nahanap natin yung velocity. And acceleration is equal to plus minus 9.8 meters per second square. So, malalaman natin kung ipa-plus or minus ba natin yung gagamitin natin. So, review lang muna tayo. Ano ba yung mga projectile motion formulas na meron tayo? So, first one, we have h is equal to 0.5 at square. Yung height daw ay equal sa 0.5 or 1/2 times mo ng acceleration times mo ng t square, yung time. Alright, next naman is the range. So, we have Vx times mo ng time. Vx again is the horizontal component ng velocity at yung initial niya. Third one, we have the final velocity is equal to the initial velocity plus acceleration times time. So, mapapansin mo Vy. So, we're looking for the vertical component. And fourth formula, velocity is equal to the square root of the quantity, the square of the horizontal component of the velocity plus mo sa vertical component ng velocity, i-square mo din yun. So, parang Pythagorean theorem lang. Paano natin malalaman yung V kung initial or final? Pwede mo siyang gamitin yung V na yan for initial. Basta, initial din yung horizontal and vertical. Kung gusto mo hanapin yung final velocity, so dapat final velocity din yung nasa loob ng formula mo. Or nasa loob ng radicand. So, yung b square x na yan, kung final ang hinahanap mo, dapat final din yung dalawang b na yan na nasa loob ng radical sign. And lastly, we have theta is equal to inverse tangent or arc tangent of Vy over Vx. So yung theta, that will be the angle. Alright, so dahil hinahanap natin ang Vx, anong formula na pwede natin gamitin kung meron tayong height and range and acceleration? So for Vx, mahanap natin siya. We can use the formula R is equal to Vx times time. Kaso wala tayong time. But we have the height and the acceleration. We can use the first formula. So height is equal to 0.5 at squared. Alright, so i-substitute natin yung values na meron tayo. So that will be 25 is equal to 0.5 times 9.8 times mo ng t squared. And t squared is equal to 25 over 4.9. So algebraically, t is equal to 2.26 seconds. Now, let's solve for the initial velocity. Meron tayong range is equal to initial velocity times time. So let's substitute the values. 40 is equal to the initial velocity times mo ng 2.26 seconds. So, hindi ko muna nilagay yung mga units para space saving. But make sure yung sa final answer dapat merong units. So, initial velocity, algebraically, 40 divided by 2.26, that will be 17.7. And the answer will be 17.7 meters per second. Alright, so problem solving type 1, number 2. A ball rolls horizontally off a cliff at a speed of 40 meters per second. It takes about 10 seconds for the ball to hit the ground. What is the height of the cliff and the distance from the base of the cliff to the ball when it hits the ground? So, hinahanap dito yung height and range. Yung bola daw gumulong horizontally off a cliff sa may velocity daw ng 40 meters per second. Tapos, tumagal daw to ng 10 seconds bago siya makapunta sa ground or ma-hit yung ground. So, hinahanap dito yung height and range. Right, so we have the given. The initial velocity is 40 meters per second and time is equal to 10 seconds. Acceleration can be either plus minus 9.8 meters per second squared, depending on the question. And we're finding for the range and height. So, anong formula na pwede natin gamitin para mahanap natin yung height and range if we have the time, we have the acceleration, and the velocity? So, we can use the first and second formula. So, I'll start with the height. So, I'll substitute the values. So, height is equal to 0.5 times mo ng 9.8 times mo ng 10 squared. So, algebraically, the answer will be 490. And that will be 490 meters. Sunod naman natin yung range. And range is Vxt. So, we have 40 meters per second times mo ng 10 seconds. 40 times 10, that will be 400. And the range will be 400 meters. So again, to the question, what is the height of the cliff and the distance from the base of the cliff to the ball when it hits the ground? The height is 490 meters and the range is 400 meters. Alright, so problem solving type 1, number 3. A ball is kicked horizontally from the cliff that is 650 meters tall and lands about 700 meters from the base of the cliff. Calculate the final speed of the ball just before it hits the ground and find the angle of the ball relative to the x-axis. So as usual, lagay natin yung given. We have the height is 650 meters. The range is 700 meters. Acceleration can be either plus minus 9.8 meters per second squared. And we're finding for theta or the angle and the final velocity bago ma-hit ng ball yung ground. So, para mahanap natin si final velocity for the y component, we need to have the time. Remember, the initial velocity of the vertical component is 0. Vy is 0, but we don't have the time to compute for it. Although we have the acceleration, kaso kulang tayo sa time. We can solve for time if we have the height and the acceleration. So, pwede natin gamitin yung h is equal to 0.5 at squared. So, let's substitute the values. That will be 650 equals to 0.5 times mo ng 9.8 times mo ng t squared. So, t squared is equal to 650 over 4.9. And algebraically, t is equal to 11.518 seconds. Alright, so dahil may time na tayo, we can solve for Vx. And R, the range is equal to Vx times time. So, algebraically, let's substitute the values. That will be 700 is equal to Vx times mo ng 11.518. Hindi ko muna lalagay yung units again just to save space din. But make sure the final answer dapat nandun yung units. So, 700 divide mo ng 11.518, that will be 60.77. So, Vx natin is 60.77 meters per second. Next, we have to find BYF, or the final velocity in the vertical component. We have the formula BYF is equal to BYI plus mo ng acceleration times time. We know that the initial velocity at the vertical component is 0. Diba? Pag nahulog yung bola, magsisimula mo na siya ng 0 meters per second in the vertical component. So, substitute muna natin yung values. That will be BYF is equal to 0 plus mo ng negative 9.8 times mo ng 11.518. Alright, so bakit ako nag-negative naman dito? We're looking for the final velocity. Mapansin mo, pababa yung bola, di ba? So, sa Cartesian plane, vector quantity, pababa ka, pa-south, so magne-negative ako dito. So, the final velocity will be negative 112.876 meters per second. Alright, so we have the final velocity now for the vertical component, and we also have the Vx, that is 60.77 meters per second. Ang tanong, bakit yung sa Vx, wala na siyang final and initial? Remember, ang acceleration hindi nakaka-apekto sa horizontal component. So, as is lang yung Vx na yan. So, yung Vx na 60.77 meters per second, bago mag-hit yung ground, aim pa rin yung horizontal component niya. Aim pa rin yung Vx. Now, going back to find the final speed of the ball just before it hits the ground, so we have the formula for the velocity. We're looking for the final. So that will be V is equal to the square root of the quantity b square x plus b square y. So algebraically, lagyan mo lang sa calculator the square root of the quantity 60.77 square plus the quantity negative 112.876 square. Yung lalabas dyan na answer, that will be 128.915 meters per second. We're looking for speed, so kunin lang natin yung positive answer. The positive naman siya, so that will be 128.915 meters per second. Yung speed ng ball just before it hits the ground. Alright, next one. Find the angle of the ball relative to the x-axis. So we have the formula, arctan or inverse tangent of Vy over Vx. So lalagyan natin siya as is. Arctan of the quantity negative 112.876 over 60.77. And the answer will be negative 60.70 degrees. Alright, so ano magiging itsura niya sa Cartesian plane? So dahil negative yung angle mo, magiging clockwise yan. As in the image dun sa screen nyo. So final answer natin, that will be negative 60.70 degrees. That's the angle of the ball relative to the x-axis. And the final velocity just before the ball hits the ground, that will be 128.195 meters per second. Okay, let's move on. Problem solving type 2. So, problem solving type 2 natin, papansin mo, level ground lang siya. Wala siya sa cliff. So, A, B, and C. So, first question. A ball is kicked off the ground at an angle of 60 degrees at a speed of 30 meters per second. Find the peak height of the ball. Letter B, determine the flight time before it hits the ground. And letter C, determine the horizontal distance. So, ito yung illustration ko. Ayan, mapapansin mo A, B, and C. So, B, bago tinduktok or yung zenith. Bago bumaba yung bola. And yung C, yung pag natamaan niya na yung ground. So, let's construct the table. We have the given theta or the angle as 60 degrees. The velocity, the initial velocity, that will be 30 meters per second. And the height, yung hinahanap natin, peak height. Acceleration can be plus minus 9.8 meters per second squared, depending on the question. Right, so as you can notice, meron tayong formulas dito. Ito yung formulas kanina. At yung sa second column, that will be the super formulas. Bakit siya tinawag ng super formulas? Kasi it will save you a lot of time para masagutin itong mga klase ng type 2 and type 3 problem. So let's start with the first super formula. Height, maximum height dito, pag ganitong problem, height is equal to b square sine square theta over mo ng 2a. And next one, we have the time. Ito yung flight time ng projectile mo. Time is equal to 2v sine theta over a. So, complete hang time niya. Third one, we have the range. Range is equal to v squared sine times 2 theta over a. So, you can use this formula for the range only for type 2 problems. At yung pang-apat, that will be tangent theta is equal to 4h over r. We also have the last formula for the super formulas. Another range formula, r is equal to v cosine theta times time. That's for type 3. Okay, this one naman, nagamitin nyo lang for type 3 problem pag hinahanap nyo yung range. So for finding the peak height of the ball, and theta is 60 degrees, and we have v is equal to 30 meters per second, and acceleration is same, plus minus 9.8 meters per second square. For that one, anong formula ang pwede natin magamit dito? So we can use the super formula for finding the height. That's h is equal to v squared sine square theta over 2a. So that will be h is equal to 30 square times the quantity of the square sine 60 degrees over mo na 2 times 9.8. And h is equal to 900 times mo ng 0.866 square over 19.6. And the answer will be 34.44 meters. Okay, so going back to the problem, we have the given, the angle is 60 degrees, the velocity or the initial velocity is 30 meters per second, the height is 34.44 meters, and we're looking for time. Determine the flight time before it hits the ground. And the acceleration is plus minus 9.8 meters per second square. Anong pwede natin gamitin na formula? So, dahil meron naman tayong angle, velocity, and height, and acceleration, we can use the super formula for getting the time. That is, time is equal to 2v sine theta over a. So, let's apply it. And let's substitute the values. T is equal to 2 times 30 times mo ng sine 60 degrees over 9.8. And algebraically, the answer will be 5.3 seconds. Ganun na siya kabilis. Kung meron kang angle, you have the initial velocity, and also acceleration is always given. You can solve for time by using that formula. Alright, so again, ayun yung flight time ng bola. If you just want to get yung from A to B, so didivide mo lang ng 2. Tatanggalin mo lang yung 2 sa formula. So yung formula again for T is equal to 2V sine theta over A. That's A to C. A, pumunta ng B, tapos pumunta ng C. Ayun yung formula ng time na yun. Yung sa bola. Alright, so last part tayo ng problem, determine the horizontal distance. So dito naman, nagkaroon na tayo ng time. So anong formula ang pwede natin gamitin dito? We can use the super formula in finding the range. So that will be range is equal to v squared sine times 2 theta over a. So let's substitute the values. The range is equal to 30 square times mo ng sine times mo ng 2 times 60 degrees over 9.8. And the range will be 79.53 meters. It's a reasonable answer. So you have the height, the maximum height or the peak height, that will be 34.44 meters. And for the range, that is 79.53 meters. And yung flight time before it hits the ground, that is 5.3 seconds. Alright, next problem tayo. Problem solving type 2, number 2. A ball is kicked off the ground, reaching peak height of 30 meters and lands 50 meters away. Calculate the initial speed and the angle above the horizontal axis of the ball when it was kicked. So para dito sa problem na to, let's solve muna kung ano yung mas madali. So we can solve for the angle kasi meron tayong height and the range. So we can use the super formula, that is tangent theta is equal to 4h over r. And for this one, you can only use this at type 2 problems. Substitute ko na, tangent theta is equal to 4 times 30 over 50. So kunin mo yung sagot niyan, kunin mo yung arctan or inverse tangent, and the answer will be 67.38 degrees. So yung angle na kinik mo yung bola at may range ka na 50 meters and height of 30 meters, the angle is 67.38 degrees. Okay, yung isang part pa ng problem, calculate the initial speed of the ball when it was kicked. So range is equal to v squared sine times mo ng 2 theta over a. We can use that one. So meron tayong range is 50 and yung angle meron na rin tayo at yung acceleration at 9.8. Alright, you may be wondering bakit positive ulit yung acceleration ko na 9.8. Because the question is, you're finding for the initial speed. Again, speed is a scalar quantity, so dapat positive siya. Algebraically, v is equal to 26.27 meters per second. Pero going to solve it, mas maganda sana kung diretso siya sa calcu. Yung rounding up, sa dulo na lang, sa final answer na lang tayo. Para mas close tayo dun sa accurate answer. So again, the final answer, the angle is 7.38 degrees and the initial velocity, that will be 26.27 meters per second to have a maximum height of 30 meters and a range of 50 meters. Alright, next one, problem solving type 2, number 3. Let's have an easy one. Teddy jumps off the ground at a speed of 12 meters per second. At what angle did he jump from the ground if he landed 2 meters away? So, hinahanap lang dito yung angle. So, let's just put the given. May initial velocity tayo na 12 meters per second. Ang range mo at is 2 meters. Acceleration is plus minus 9.8 meters per second squared. And we're looking for the angle, theta. We can use the third super formula. That will be r is equal to b squared sine times 2 theta over a. So, let's substitute the values. We have 2 is equal to 12 squared times mo ng sine times 2 theta over 9.8. 19.6 is equal to 144 sine 2 theta, and 2 theta is equal to the arc sine of 0.1361, and the angle will be 3.911 degrees. Alright, so let's move to the problem solving type 3. So this kind of question, mostly nasa taas ka ng cliff, tapos hinipa yung bola with an angle, at bababa siya pumunta sa C. From A to B at C. Alright, so number 1 question. A ball is kicked from a 500-meter cliff at a speed of 50 meters per second at an angle of 50 degrees. The first part of the question, find the maximum height of the ball above the ground. Letter B, find the time it takes for the ball to hit the ground. Letter C, find the horizontal and vertical component of the ball's velocity just before it hits the ground. Letter D, find the range. And letter E, find the final speed and angle of the ball just before it hits the ground. Okay, so mukhang talagang nandito na lahat sa isang tanong na to. First part muna tayo, find the maximum height of the ball above the ground. Remember dun sa part 2 problem, para makuha natin yung maximum height, gagamit tayo ng h is equal to v squared sine squared theta over 2a. So, hindi man katulad to ng third type ng projectile, kaso mapapansin mo, it doesn't matter kung saan yung C eh. Okay? So, we can use that formula to find the maximum height. So, let's substitute the values. H is equal to v squared sine squared theta over 2a. So, that will be h is equal to 50, kasi 50 meters per second. Square mo yun, times mo ng sine, 50, tapos square. So, h is equal to 2,500 times mo ng 0.586824. So, na-square ko na yun yung sine 50. Divide mo ng 19.6 and the height is 74.85. That's the maximum height. But the question is, find the maximum height of the ball above the ground. Okay, remember, you're 500 meters above the ground. So, what you can do is, you must add that 500 to that 74.85. And the answer will be 574.85 meters. That's the maximum height of the ball above the ground. Alright, next part of the problem, find the time it takes for the ball to hit the ground. Remember, dun sa part 2 problem natin, meron tayong A to C. So that will be time is equal to 2v sine theta over A. Hindi natin pwedeng gamitin to ng ganun-ganun na lang dito sa type ng problem natin. Kasi yung A to C mo, ka-level niya yung ground. Eh dun sa type 3 problem natin, yung A to C, hindi niya ka-level yung A at C, di ba? So what we can do, kunin natin yung kalahati lang. Kasi parehas na naman yung A to B at yung A to B ng type 3 and type 2. So ang gagawin natin, yung sa formula na 2b sine theta over A, tatanggalin lang natin yung 2. Again, that's the time from the trajectory of the ball from A to B. Okay? So mamaya na natin kukunin yung time from B to C. So from A to B, ang time nun is equal to V sine theta over A. So time is equal to 50 times mo ng sine times mo ng 50 degrees over 9.8. And time is equal to 76.604 over 9.8. And the answer for A to B, yung bola from A to B, that's 3.908 seconds. Alright, next one, we need to find yung time from B to C. Remember, naalala niyo yung sa type 1 problem natin, if we're going to get the time from B to C, we have h is equal to 0.5 times at squared. Acceleration times time squared. Alright, so let's substitute the values. 574.85 kasi tinan mo yung B to C, yung height nun, that's 500 plus 74.85. Is equal to 0.5 times mo ng 9.8 times mo ng t square. Again, ginamit ko yung positive value kasi time ang hinahanap natin. So I don't want a negative value in time. So t square is equal to 117.316 and t is equal to 10.83 seconds. Final answer natin, pagsamahin mo lang yung time from A to B and B to C, so that will be 3.098 seconds plus mo ng 10.83 seconds. And the final answer will be 14.738 seconds. Alright, so 2 down, 3 to go. Next part of the question, find the range. So paano natin makukuha ang range? So let's check again the formula. So we have the given, delta y is negative 500 meters. And h is 74.85 meters. V is 50 meters per second. Theta is 50 degrees. And time is 14.738 seconds. So, anong pwede kong magamit dito for the range? So, we have the super formula for type 3 range. That is, range is equal to V cosine theta times mo ng time. So, we cannot use the third part of the super formula kasi pang type 2 lang yun. So, R is equal to V cosine theta times time. R is equal to 50 times mo ng cosine 50 degrees times mo ng 14.738. And the range will be 473.67 meters. It's a reasonable answer naman. Alright, so 2 to go. Find the horizontal and vertical component of the ball's velocity just before it hits the ground. So we're looking for VYF and for VXF. Okay, so naalala nyo sa vectors, to find the horizontal component, you just have to get the cosine V cosine theta. And for VYF, that will be V sine theta. So let's get the answers now. Vx is equal to 50 cosine 50 degrees. That will be 32.14 meters per second. And for Vyi naman, or the initial velocity for the vertical component, that is 50 sine 50 degrees, is equal to 38.30 meters per second. Again, we're looking for the final velocity for the horizontal and vertical component of the ball's velocity just before it hits the ground. So, hindi pa ito yung final answer. Okay, bakit yung Vx wala na siyang initial and final? Remember, again, yung acceleration, it doesn't affect the horizontal component. So, kung ano yung Vx mo nun sa simula, ganun din yung Vx mo sa huli. Alright, so dahil nahanap na natin yung Vyi, we can now find the Vyf, the final velocity, for the vertical component. Again, hindi pa siya final velocity. That's just for the vertical component of the final velocity. And we have the formula, Vyf is equal to Vyi plus mo ng acceleration times time. So algebraically, I'll just plug in the value. So Vyf is equal to 38.3 plus mo ng negative 9.8 times mo ng 14.738. So that will be 38.3 minus mo ng 143.4324, and the final velocity in the vertical component is negative 106.13 meters per second. You have to be careful with the sign. Bakit ako nag-negative dun sa 9.8? Kasi pababa na yung bola eh. So, mapapansin mo, you're above the 500 meters, diba? Eh, pagdating mo ng sa B to C, bababa siya. So, you have to take the negative value. So, the final velocity mo, talagang magiging negative siya. Alright, so, going back to the question, find the horizontal and vertical component of the ball's velocity just before it hits the ground. As you can see, and for VYF, that is negative 106.13 meters per second. At yung sa horizontal component mo, that will be 32.14 meters per second. It will not change. Alright, so last part na tayo ng problem. Find the final speed and angle of the ball just before it hits the ground. So ito yung mga given natin. Lagay ko dun sa table. Anong gagamitin nating formula para mahanap natin yung final speed and angle of the ball just before it hits the ground? So we can use V is equal to the square root of the quantity b squared x plus b squared y. So if we're going to find the final velocity for V, make sure sa loob ng radical sign mo dapat, final velocity din yon. Nasa final din x and y components. At nasolve naman natin kanina yung horizontal and vertical component for the final velocity. So for V, F, that will be equal to the Pythagorean theorem lang. So the square root of the quantity 32.14 square plus mo ng negative 106.13. So VF is equal to the square root of 1032.9796 plus mo ng 11,263.5769. And get the square root of that, and the answer will be 110.89 meters per second. So yun yung final speed. But meron pa tayong hinahanap, angle of the ball just before it hits the ground. Alright, so for that one, angle theta is equal to arctan of Vy over Vx. So again, ang Vy mo, that is negative 106.13 meters per second. Over mo ng 32.14. You have to keep the negative sign because angle naman to eh. It's a vector quantity. So the answer will be, so theta is negative 73.15 degrees. Yung sa screen sa lower right, dahil negative siya, so you have to go clockwise. Relative to the x-axis pa rin yan. It's negative 73.15 degrees. And that's the end of the video about projectile motions. Next video natin will be about free body diagrams of the forces like F-grab and F-frict. If you would like to comment or suggest another math and language video or kung mayroon kayong assignment, comment down below. Again, this is James, your math and language instructor. Please like and subscribe. Thank you. Bye-bye.